So the first lab is manipulating WebSocket messages to exploit vulnerabilities. The initial message brought over through plaintext, but according to Burp Suite, as I sent the second message, just a single bracket, it gets encoded client-side into HTML. So, if a user has software such as Burp that allows the user to send certain characters without them being coded, it allows them to insert code of their own choosing, such as the code that causes the pop-up here. So the solution here is to encode it on both ends if possible, and if not, encode it on the server side, because anything from the client side is not to be trusted. The second lab is manipulating the WebSocket handshake to exploit vulnerabilities. Handshake being the operative word. Sender's first message. Go to history. Find our initial sending of that message and then send it to the repeater. Once that's done, we can actually edit the message to include code and send it again. However, there is a security measure in place, and we are blocked from trying to send any more messages. Attempting to reconnect fails without any further tampering. But if we add x-forwarded for 1.1.1.1 at the top of the handshake, rather than just anywhere, sometimes that we can bypass our IP being blocked, and then try and insert more code, such as the code here that allows us to trigger the alert. Moral of the story here is to test for anything that allows certain blockage to be passed. So, the third lab is reflected DOM cross-site scripting. So we turn intercept on Burp Suite's proxy tool. Search for a random string. In what we intercepted, we should see a string labeled search results, which is parsed with an eval. Apparently, quotation marks are being filtered out, but backslashes are not. So if you do a backslash quotation mark, that actually ends the string and allows you to insert code such as that, which allows us to trigger the alert. Moral of the story: filter out all characters that have significance in code. Have someone check if you've got everything. So this next lab is DOM cross-site scripting inner HTML sync using source location.search. This one is fairly simple. There is no filtering for code. Just by typing in the HTML in the search bar, image search equals 1, on error alert 1. There is no checking for whether or not a search result, first of all, is just plain text and not code, and for second, is readable text instead of an image. So it just runs that code, encounters the error, and triggers the alert. So once again, always filter your inputs, always double check, make sure it is the same type of data that you asked for. So this next lab is DOM cross-site scripting in jQuery Anchor href attribute sync using location.search source. Basically, the URL itself has a lot of potential for code insertion. As you can see, I type a random string after the slash, and that random string appears in the code itself. So by changing the return path to not having the slash and just having arbitrary code, loading the page runs that code. As you can see, there's an alert. So the lesson here is to make sure that your URL is not does not have too much potential for code insertion, and that if there are special requests, they are not in the URL for people to notice and modify. Alright, this next lab is DOM cross-site scripting, AngularJS expression, single brackets, and double quotes, HTML encoded. So the site is built in such a way that if we search for random string of numbers, random alphanumeric, Then we inspect element and search for that. So if we insert this code here, the brackets, if I remember correctly, are a way to insert values into strings without ending the string. I remember that from Python. So apparently must work the same way. Constructor alert 1. So in theory, if we search this, yep, we do get a pop-up. Once again, never ever echo user input directly into a string without filtering out ways that they can alter it beyond the limits of a string. All right. So this next lab is stored DOM cross-site scripting. An attempt to prevent cross-site scripting, the website uses a JavaScript replace function to encode angle brackets. However, when the first argument is a string, the function only replaces the first occurrence. Exploit this vulnerability simply by including an extra set of angle brackets at the beginning of the comment. Okay. All right. Good to know. So yeah, just like the instructions say, visit it, leave a comment. And it is, oh, I just had to refresh. Yeah. So, key vulnerability, if filtering out characters that would, if sanitizing characters that would allow you to insert code, make sure it works beyond the first instance. Simple enough. This next lab is DOM cross-site scripting using web messages. So post a message. So go to the home page. Contains an add event listener that calls for a web message. Let me just see if I can find that. And what do you know? It's right there. The exploit server at the following. Change. All right. Exploit server. So that body. Or lab ID. All right. Store and deliver. So if I'm making a guess, this is what happens here. iframe source. That's the victim site. Unload this content window post message. Okay, so it's sending a message to the victim site. Message is image source 1 on error alert. Okay, so it creates an error, and then on that error, it will bring a pop-up that should, in theory, include the document cookie, even though usually it's blank. All right, deliver to victim. And yeah. So once again, general theme is don't accept data from sources that you can't verify, that you do not control. All right, the next lab, and probably the last lab that I'll be able to fit in this, is DOM cross-site scripting using web messages and a JavaScript URL. An event listener listens for a web message, contains a lot of index of that looks for one of the strings. Okay. HTTP, HTTPS, contains location that href. Just going to verify. Fair enough, right there. All right, got an exploit server. Okay, so it sends a message to the listener. JavaScript alert, document.cookie / HTTP. So it's JavaScript code with an alert, but it happens to, okay, it just happens to contain HTTP anywhere in the message rather than explicitly at the beginning. So that's where it's, okay. Store, deliver to victim. Okay. So moral of the story, don't just check that something's anywhere in a string in order to verify it. Check that it is exactly in the place you want it to be if there's a specific place that it's supposed to be. Simple enough.